Hi everyone, my name is Minda. I am the local lead for San Borondón, Guayas, Ecuador, and I will be speaking today about solving problems through computational thinking. When we listen to the term computational thinking, we tend to think about computers, robots, and artificial intelligence. But actually, no, computational thinking is not only about computers or machines. Computational thinking is actually a process by which we solve complex problems. And how do we do this? Well, we break a problem into different units. That's the first step, decomposing the problems. We break the huge problem into smaller pieces so that we can address each module or each part independently. Then within those specific modules, we find patterns, things or variables that we find are constantly being repeated in the problem. And then we use abstraction to be able to compare and contrast this problem or this challenge we're presented with another similar problem or situation that we might have actually faced in the past. After we do this decomposition, pattern recognition, abstraction, we enter the process of developing algorithms. An algorithm is a strategy or a step-by-step procedure that will allow us to solve the problem and also that we can later use to replicate the solution when we face the same problem or when we face a similar problem. So how is it that we are using this process of computational thinking when we are participating in this International Space Apps Challenge? Well, Space Apps is all about computational thinking. Whether you use a computer or whether you use any tools to address problems that are presented by NASA, we need to actually decompose a problem, find patterns, compare this problem to experiences that we have faced in our lives, and create the proposal, create this strategy of or set of steps that we need to implement in order to reach our goal. So that is why we believe that for all of our San Borondón community, it is very important to participate in this kind of hackathon, in this kind of events, to enhance our computational thinking capabilities. Last year, most of our participants were interested in solving the rising water challenge because our location is really close to many rivers. We're actually in an area where we have our own river, the river that is part of our city, and we're also surrounded by other areas that also have a lot of water, a lot of flooding whenever we face seasons, rainy seasons. So this was the challenge from 2019 in which most of our participants were focused. And actually they used the computational thinking process to be able to figure out ways on how to make our community aware of the rising waters issue and present proposals to address this problem. So, well, the solution that we found the most appealing was a viewer which allowed us to, in 3D, experience how our location, how San Borondón will look like if we didn't make the community aware of rising sea levels, rising water levels. So how did the participants do this? They used these lenses, these globes, 3D viewers, and they were using NASA's data. They linked that data to a map. So every time they would scan with the gloves the map, they would pick a specific location in the map, and they will be able to see with their lenses. How is it that this exact location would look if it was flooded? So that is computational thinking. It is used in everyday situations. It is of huge importance. People at Google use it to create software like Google Maps, Google Earth, which allow us to view different parts of the world, different addresses, and they apply also computational thinking to come up with the solutions to be able to figure out how to actually portray different locations and how to make this available to the whole public. Know that it is a process that we use every day. It is composed of four main steps: decomposition, pattern recognition, abstraction, and the creation of algorithms, which, although it sounds like a very complex word, it is only centered in developing this strategy of series of steps to achieve a goal. So I hope you enjoyed it and it was useful for you. You could research more into computational thinking to be able to do better at space apps and create even more attractive solutions for the challenges proposed. So, bye bye.